Okay, for homework 329, I'd like you to check your work or copy it down if you need to, and then write down the 5 words to show me that you listen. All right, first one has you write short sleeve shirt. They tell you that short sleeve is X. They tell you that long sleeve is Y. They tell you to graph this using only 2 points. The equation I'm going to put together is $2 for every short sleeve. They tell you X is short sleeve plus $3 for every long sleeve Y equal to 300. That's going to be the equation that I'm going to use to graph using the X and Y intercept. So let me try to show you that. On this next page, they'll give you this graph. Here's my equation that I got from that word problem there. So what I'm going to do here is graph it using the X and Y intercept points only. So for the x-intercept, remember, for the x-intercept, you know that the y number always 0. For the y-intercept, it's the x number that's always 0. So you need to know that. So to solve these, I'm taking that 0, plugging it in where I need to go, and solve for the variable I don't have. So when I'm doing that first one, I'm going to take that 2x, leave it alone, but that 3 next to it, I'm going to replace that y with 0 because I know wherever there's a x-intercept that the y number is going to be 0. So of course, 3 times 0 is 0. That gives me 2x equal 300. Divide by 2 right there, and I could see my first value is x equals 150. Make sure that number goes right here in that coordinate. Don't put that 150 by mistake right there thinking it's the y-intercept. That is the x-intercept. 150, 0 would be a nice big point right here where you have 150 for x and 0 for y. That is the x-intercept where that line's going to cross that x-axis. Now I do the same for the y-intercept, but I plug in x is 0 for the y-intercept. So I have 2x, or 2 times 0, sorry, plus 3y equals 300. 2 times 0 is 0. 3y equals 300. Divide by 3, and I'll get my first value for y, which is 100. Put that right here. Plot those 2 points. 0, 100 would be right on the y-axis. That is the point 0, 100 for x and y. And now the last piece is to draw a line between those 2 points. You don't want to leave that blank. Use the line feature to draw that line connecting those 2 points. First word is surf. Surf. All right, here we go. For this one, we want you just to write the system of peaches and watermelons. So 3 peaches would be 3p plus 5w equal 1250. Keep those all together. Don't mix the parts. The other part, 4p plus 5w equals 1350. The only way you're going to miss this one is if you by mistake, instead of put a plus in there, you maybe try to times them. You don't want to times those. The other mistake you might make is maybe mixing up the price numbers. So try to be precise. All right, so that is 3p plus 5w equal 4p plus 5w equal. All right, here we go. Next problem. For this one, they give you an equation up on top, and then they give you some more, and they want you to see if the math that I'm doing to them have kept them equivalent. So here we go. That first set, looking at it, they give me the exact same equation, so I know that's equivalent. But looking at that bottom one, what it looks like they did was take that bottom row and times everything by -1 all the way through. If you do that, that will give you -1x plus 3y equals -40. If you go all the way through, and you can see it has -x plus 3y, but it's missing this negative right there. Just missing that negative makes this no. Those are not equivalent. If that negative would have been there, that would have said yes, they're equivalent. They look different, but they're still the same. But that is a no. That bottom one was almost equivalent, but that 40 being negative, that makes that a no. Let me try to clean this up a little bit. All right, that next one, looking at it, it looks like they're attempting to take that top row and times everything by 2. That's what it looks like all the way through. Remember, triple distribute will give me 2x plus 2y equal 440. This is almost that equivalent equation, but because that 220 is left 220, really it's not equivalent. If that would have been 440 right here, that would have been a yes. If this would have been negative right here, that one would have been a yes. But since those pieces are missing, this is another no. They are not equivalent. That bottom one, though, I believe is the only yes. What they're having you do, it looks like, is instead of timesing that top row by 2, looks like they're taking that top row and doing the old -1 trick all the way through, which would give you negative x minus y equal negative 220. And again, even though that looks different, because I times everything by -1, it's still equivalent. And of course, the bottom one is exactly the same. So this one is a yes. They are equivalent. Even though negative x minus y equal doesn't look the same, they are equivalent. Even though negative x plus 3y equal negative 40 doesn't look the same as this, they are equivalent. These two down here had those mistakes that kept them from being equivalent. All right, second word is snow. Snow. All right, for this one, I'm going to give you a hint. Any number that is divisible by this denominator, that 3, those are the ones I would be plugging in first. Anything with a 3 in it, you want to make sure that fraction is going to go away. So when I plug in, I'm going to start with a 3. I'm going to see for both equations what I get for y when I replace that x with 3. And I'm jumping straight to that 3 because I know 3 is dividable by 3. I know I'll have no fraction there. So when I do this math to see what y is, this is going to be over 1. I'm going to times straight across, if you remember, but that gives me negative 6 over 3 plus that 6 that's still there, which is y equals negative 2 plus 6. That is y equals 4. And what that means right there, that means when I replace that x with 3 in this equation, it gave me 4 for y. If I do that for the other equation, see what y is when I plug in 3 for x in this one. Let's see. 3 times 1/3 really is straight across 3 over 3, which is 1. But that becomes 1 plus 3. And of course, 1 plus 3 gives me 4 again. So I could see for this one also, when I plugged in 3 for x, it gave me 4 for y. This is the solution set. And then make sure you put your answers in the right place. Don't put that 3 right here in the y value box. Don't want to do that. That 3 goes right here for x, and that 4 is the value that both of them spit out when you plug in 3 for x. All right, next problem. This one, we're going to write the system, solve it, and explain one. So here I go. I have 6 apples plus 5 bananas equals to 20. Bottom row, I have 3a plus 7 bananas equals 1450. I'm going to take this bottom row and times everything by -2. And the reason I do that is this will end up being -6a, which will cancel that 6a above it. That's what I want. I'm going to take the time to rewrite both. Here I go. So 6a plus 5b equals 20. The bottom row, -6a, -14b. And then on my calculator, because I'm not going to trust my arithmetic, -2 times 14.5 is -29. Now when I add these up, because these are opposites, they'll cancel. 5 take away 14 gives me -9b. 20 minus 29, -9. Opposite of timesing by -9, dividing by -9. Don't just divide by 9. Cancels away. Gives me half my answer B. But just remember, part of this problem is making sure that you know that that B number is $1 for every one banana. That's what that answer really, really means. Define the A number. I'm going to take that equation, any one of them, and replace that B with the number I know B is. I know B is 1, so I'm going to take that top equation and replace B with 1, and now solve for A, which gives me 6A plus 5 equals 20. Take away 5 on both sides. Gives me 6A equal 15. Divide by 6. And that will give me the price of my apples. So 15 divided by 6 gives me 2.5. On the test, they're going to have you explain what those mean in words. So make sure on test day you tell me A, and don't mix that up. A is 2.5, B is 1, but then it says explain 1 in terms of the context of what it means. So you could say the answer A equals 2.5 means $2.50 for every one banana. I'm sorry, not banana. For every one apple, if I'm doing the A1, of course. If you did the B1, 1 represents $1 for every banana. But if I'm doing A, the answer A equals 2.5 means $2.50 for every one apple. So at least write something like that. All right, next problem. Here we go. This one, they want you to write the inequality and then graph it. Second word is snow. I'm not sure if I said the second word, but snow. All right, so here we go. $2 burritos. They're going to tell you burrito is X. Y is going to be soda. So if I write this 2X plus 1Y or just Y, at most, if you look at it, at most is the less than or equal to direction. It's not more than or equal to. That's at least. At most is the less than or equal to direction. Can't have any more than 8. Solve this inequality for y and then graph it. So take away 2x on both sides. Bring this y down. Don't put an equal there. Make sure you bring that inequality down. Don't switch that negative to the 8. It's negative 2x plus 8. 8 tells me where to put my first point on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, right here. And then looking at that negative 2 number made into a fraction would be negative 2 over 1, which means right 1 down 2. Right 1 down 2. That is my slope, my rate of change. Right 1 down 2, right 1, down 2. Be able to stair step the opposite way. Up 2, left 1, up 2, left 1. This line, if you look at it, because of the inequality, is going to be a solid line, not a dotted. Because the inequality is the less than direction, the one that looks like an L, it's going to be shaded below the line. This is below, down here. This is above. So when I draw my solid line, because this is a solid line because of that inequality, I'm going to shade everywhere below it. I'm going to put arrows on the end of my line. And then since this is less than, I'm going to shade below. So that is my graph. For this real world problem, remember Marshall's class, we're dealing with quadrant 1 here. And I had you explain what one of those solution points means as a coordinate. So if I look at that point, which is 2, 3, I had you understand in the context of this problem that that is a combination of 2 burritos, because burritos is the X number, with a combination of 3 sodas. If you buy that, that will keep you under the $8. Or I could buy 1 burrito and 4 soda, or I could buy 3 burritos and 1 soda, or I could buy 4 burritos and 0 sodas. All those numbers are good. All right, let's keep going. Next problem. All right, this one I'm going to have you graph them and then solve them. I'm sorry, graph them, solve them for y, and then graph them. So this first one here, I'm going to take away x on both sides, solve for y. That x is positive. I'm going to remember to bring down the negative with the y. Remember to write this as negative x plus 2. Don't put the negative in front of the 2. This is negative 1 right here times y. The opposite, dividing everything by negative 1. That will make this y positive. That will take that inequality for this blue line and switch it to the less than direction. This negative 1 divided by 1 is going to give me positive 1 over 1x, or the way we really write it, just plain old x. And then that 2 divided by negative 1 gives me negative 2. So if I graph that, that will be at negative 2 on the y-axis. That slope of being 1 over 1, right 1, up 1, right 1, up 1. This line is going to be dotted because it's missing the equal line under there. So if I draw a blue dotted line, I'll show you how to make it dotted. For these systems, draw your lines really long. You don't want to have short lines, nice and long. This line will be dotted, so I'll make it dotted because of the inequality. And now the inequality says less. This is less than. That is below. Less is always below. More is above. So less than, I'm just going to shade a little bit under so I could get an idea of where my other one's going to go before I fill it in. So this is going down. My next one, to solve this, take away 3x on both sides. Those will cancel away. Bring down this 4y. Don't put an equal in there. Keep that inequality. Keep that negative 3x plus 12. And then right here, dividing everything by 4. Cancel these away and gives me my equation in red to graph. That's going to be y less than or equal to, no switching because I didn't divide by negative, negative 3/4 x plus 3. 12 divided by 4 is 3. So I go up to 3 on my y-axis and then right 4, down 3. Right 4, down 3. Be able to stair step opposite way. Up 3, left 4. Up 3, left 4. Draw your line. For this one, it's going to be a solid line. it's going to be below. This one is less than 2, going to be shaded below, just like the red one. So if I graph this one, solid line because of my inequality. And then this one I can see because it's less than, shade a little bit below. And then remember how I graph these, find that one part. Remember there's 4 parts. Find that one part of your graph where the shading zones overlap, which should be down here in this part of my graph. Red going down and blue going down. And then we want you to be able to pick a solution point in there. Any solution point, and be able to tell me what that is. This point is 3, -2. Be able to graph it and then choose a point in the solution zone. All right, keep going. Third word is sand. Sand. All right, this one wants you to do the opposite. Write the inequalities for this graph. So here I go. This one in blue I'll do first. This dotted one has a slope of 1/1, has a y-intercept of 3. It is dotted, shaded above. The blue line here, my dotted shading above. So this one is going to be y more than, it's going to be 1x, or again, we just write x. And then that y-intercept of +3. That's that blue dotted line. The one in red, this one's slanting down. Looks like it's going right 4, down 1. Remember though, that's not -4/1. That's a slope of 1. I'm sorry. It's going right 4, down 1. Let's redo that. Right 4, down 1. That is a slope of -1/4. Rise over run. Don't say 4 over -1. This inequality is going to be solid. It's shading above this line too. So both of them in the more than direction. This one is y more than or equal to because it is solid. And I'm sorry, it looks like, I'll retract that. It looks like the red line is shading under. So I'm going to take that back. The red line is going to be the less than direction, less than or equal to that slope -1/4. Don't forget your x. My y-intercept of -4. Those are my 2 inequalities. +3 over 1 up 1, solid, dashed line, shade above. The red one less than or equal to -1/4 -4. And then they want you to give a solution to the system, which means any point in this shaded zone, any point along this solid line, cannot pick dotted line points. Nope. Cannot pick any points outside of the zone. So it looks like this green coordinate clearly inside there. And I'm going to make sure it's clearly inside, not take a chance. -1, 2, 3, 4, 5, 6, 7, -3. So if I go to that point, it is going left 7 on the x-axis, down 3. That is the point, -7, -3. That is in the solution zone. Third word is sand. Sand. All right, for these, I just want you just to maybe write these down, but just to understand. So parallel lines have the same slope, but different y-intercepts. The way that looks on a graph are 2 lines that never touch, 2 parallel railroad track lines. The way that looks for equations is the same number in front of x, but different y-intercepts. Remember, if they have the same slope and the same exact y-intercept, they're not parallel, they're just overlapping lines, but that one's parallel. The other one, if your lines cross at a perpendicular angle and they, with your eyeball, or they write that little square symbol to show, that's how it looks on a graph. Perpendicular, that is a 90-degree angle where those lines are meeting. On a graph, the way we do it is we show slope as negative reciprocal, opposite reciprocal. If I take 1/3 and do the reciprocal of it, becomes 3/1. But not just reciprocal, opposite. If that's positive, the opposite reciprocal. So again, perpendicular lines with equations, you're looking for the slopes of opposite reciprocals of each other. That's your perpendicular look. And of course, neither two lines that cross that don't have the right angle symbol in there, two lines that neither have same slope like parallel nor perpendicular. All right. Next problem, number 10. All right, so for this one, they want you to look at the transformation and describe it, but you got to be important. This one is the pre-image where it is all starting. Don't mix that up. It's going from here to here. This is the image after the move. So if I look at point B, I'll just take a look at point B. Looks like from the original pre-image B to the new B, I'm going way to the right. Count my boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then it looks like from there to go straight down to the new B, I'm going down 1, 2, 3, 4, 5, going down 5 boxes. The way we write this rule is this. We write the X number like a coordinate and we plus 11. Because every coordinate we're going to be adding 11 to get the new coordinate. And then for the Y number, we're going to do the rule Y minus 5 because every coordinate we're subtracting 5. To show that, remember, if I take the original B coordinate pre-image, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 5, 6, 1, 2, 3, 4. Looks like -6, -6. To get the new image B, it should match my rule. I should be adding 11 to this 6 number. I should be taking away 5 from this Y number. If I do that right, 11 minus 6, this new one should be 5 because 11 minus 6 is 5. -5 minus 6, that should be, oh, sorry, looks like I wrote the wrong coordinate. Let's go back. So sorry about that confusion. That coordinate, unfortunately, the mistake that some people make like I do, I wrote the wrong coordinates. So let me write the correct coordinate for B. 6, 6, sorry about that. So technically for this rule to find the new B, I'm going to be adding 11 to my 6 number and taking away 5 from my Y number to get that new coordinate. That's how the rule affects the point. It gives me the new point 5, 1, and that should be this point right here. And that looks like it is 1, 2, 3, 4, 5, 5, 1. If you did that for every coordinate, it would be the same. Every coordinate would be affected by that rule. Every X number adding 11, every Y number taking 5 away. But on test day, write it like this. Don't mix it up. Don't put X minus 11. Don't put the 5 with the X. The right number goes with the X. The up or down goes with the Y. All right, keep going. Fourth word is mountain. Mountain. All right, for this one, they want you to chart the movement and explain it in mathematical words. I could see from this tip to this one right here, I'm going to the right, and then I'm going down. So it looks like I'm going right 1, 2, 3, 4, 5, 6, 7, and going down 1, 2, 3, 4. So what I might want to write for you, I would write the transformation, or you could say the pre-image shape 1 is translated right 7, down 4 to get the new image. So that's what I would write, something like that. Describe that motion going to the right 7, down 4. Use mathematical terms, translated, pre-image, image. All right, next problem. This one here, again, the only one that's going to work is the spinning all the way around. None of these reflection ones are going to work. If I do a reflection over the y-axis right here, and then I do a spin, that's not going to work. That's not going to get it there. If I do a reflection over the y-axis to there, and then spin it all the way around, it's not going to end up like that. I promise you, it's going to end up upside down. So you don't want to do that reflection. Don't do that. I want to do one of my spins and continue it all the way around. If I look at a 90 degrees clockwise rotation, that is to the right. That would take this and move it right here. And then if I do a 270 rotation back to the left, that would take that then all the way back here, and that's not where it ended up. So again, if I go to the right and then I switch back and go to the left, it's not going to work. None of my 180 ones work either. Let me try to show you. If I do a 180 spin, it's going to end up right here, upside down. And then if I do a quarter turn, it will no way end up back either direction I go. So that half turn one is not going to work either. Can't be the half turn one. It cannot be the one where I turn one direction and switch to the other direction. The only one that works is this one right here. Because if I do a 90-degree turn counterclockwise to the left, will put me in this section. And then if I keep going another 270, that goes 90, 180, back right here to 270. That is all the way around. That's what you're looking for. You're a quarter turn to the left and then continue 3/4 of the way to the left. You don't want to go quarter turn to the right and then switch back to the left. You don't want to do those half turns. Those aren't going to work. None of those reflection ones are truly going to work. All right, next problem. For this one, a 90 degrees clockwise rotation is a quarter turn to the right. We've taught you that a quarter turn to the right, that new point for A, you're going to switch the coordinate. The X and Y numbers are going to switch, and then you usually opposite that right one. But since there's no opposite of 0, we'll just leave it 9, 0. So I could see if I plotted 9, 0, that would be right here past that far point of 8, 1. That would definitely be outside triangle BCD. If it was smaller, maybe between 2 and 8, like maybe 0, 6, that would switch to 6, 0, which would put that right smack inside the triangle if I was to do a different point. But 9, 0 or 0, 9 becoming 9, 0 ends up outside that triangle. All right, keep going. 14, I want you to give me 2 transformations here. So for this one, I want you to see that this is the pre-image where it's starting because there's no marks on the letters. I know that's where it's starting. This next one above it is the image, the one after the move, and I know that because it has these little marks. Let's put that on that Z. It has the little marks, X prime, Y prime, Z prime. I want you to figure out two transformations. I could do a quarter turn to the left. So one possible transformation would be a 90-degree counterclockwise to the left. Counterclockwise rotation. And we say rotation about the origin, because these rules are spinning always around the origin. That is our center point here for the way we're doing rotations. So a 90-degree counterclockwise rotation about the origin. That's one way to get from the pre-image to the image. The other rule would be a 270 rule to the right. 270 to the right. That would be another way to get that 270 clockwise to the right rotation about the origin. But remember, we don't have a rule for a 3/4 turn. We do have a rule though for a quarter turn to the left. So for those of you who have been with me, remember, sometimes a 3/4 rule to the right is the same as a quarter turn rule to the left. So that would be taking the points, flipping them, and making that left one opposite to try to show you one of those points. The original X right here is the point 1, -3. If I do a quarter turn to the left, the points are going to flip, and that left one is going to be the opposite of what it once was. So -3, 1 with the flip, but then the opposite of that left number, because whenever you turn to the left, you always opposite that left one, would be 3, 1. And you can see that is right there. The new X is 3, 1, shifted to the right. So again, on this 90-degree counterclockwise rotation about the origin, or another way to get there, 270 clockwise rotation about the origin. All right, here we go, almost done. 15, for this one, I want you to see all the possible combinations. This one says reflect over the y-axis. So I'm starting here with 1. Make sure you know you're starting with 1. So that says reflect over the y-axis. If I did that, my triangle would look like that, reflected over this y-axis right here. And then to get to 2, moving 2 to the right. And I could see that one works. Reflecting that over the y-axis here, and then moving to the right 2 will cover that up perfectly. Let's take this away. So that one does work. Reflecting over the y-axis first, and then shifting 2 to the right. If I do a reflection over the y-axis again like I just did, but then move it to the left, it's moving over here. That's not what you want. So that one, no good. A reflection over the line x equals -1. Here's -1 on the x-axis. The line x equals -1 is a straight up and down vertical line, and I could see that I did not reflect equal distance over that line. So that line x equals -1 is not one of my combinations. If I look at +1 though, +1 on the x-axis, straight up and down line going through there, best I could draw, that is the line x equals -1. I could see my triangles are equal distance on either side of that line. So that one is good too. The last ones are going to have you do a reflection first and then see, or actually a translation first. So let's get rid of this line. This one says translate 2 to the left. So that would be taking this triangle 1 and moving it 2 to the left to get it right here. And then reflecting it over that y-axis. Let's see. So then if I reflect it 1, 2, 3 on this side, 1, 2, 3, it looks like it ends up perfectly on top of that. If I shove it to the right first and then reflect it, it's money. The one that doesn't work, let me show you. That one says don't shift it to the left. That one says take that original triangle, shift it to the right, which is over here. And of course, if I shifted that 2 to the right and then reflected over the y-axis, it would actually end up right there. And that's not the case at all. So that one, no good. The only ones that worked, moving it 2 to the right, reflecting over the y-axis first and then shifting it where you need it to go, reflecting over x equal 1, or moving it first and then reflecting it. All right. Last problem, last word. For this one, find the slope of this line. So I could see this line is going right 3, down 1. That is super important. Get the slope of that line. The slope of that line is -1/3. Slope is rise over run. Even though it's tempting to put that 3 on top of -1, that is not the way we write slope. Slope is rise over run. That 3 is the run. That up and down 1 is the rise. If I'm looking for parallel lines first, let's do that first. Parallel lines will have the same slope of -1/3. So first, let's look for one parallel. Look for one that has the exact same -1/3. That one is the parallel one. One that has the same exact number in front of x as that -1/3. Now the perpendicular one, a little harder. For it to be perpendicular, I need to come at this line at an exact opposite reciprocal. So if I flip that over, reciprocal it means flip it around, but then opposite it. You can't just flip it and be done. You have to flip it and take the opposite of it. So the opposite of that makes this 3/1. That is the true perpendicular reciprocal slope. That means from this line, if I go right 1, up 3, it will give me a line that forms a perfect 90-degree angle. Or on this problem, look for another one that has a perfect 3 in front of it. That is the perpendicular. 90 degrees. And then of course, if it's not the same, or if it's not the opposite reciprocal like this, that is the neither. Last word is wave. Wave. Turn in all this work with those words tomorrow for the last major grade. Good luck.